Okay, so we're doing the 2020 Danish Folkeskolens afgangsprøve I Matematik. And we're doing the 1 hour paper. So the 1 hour maths paper consisting of around 50 usually short questions. And question 1 has a table. The table shows prices for bus tickets. Children up to 16 years old, you can buy a standard ticket or an online ticket. Or you can buy a ticket for a bicycle, which is 21 kroner, irrespective of whether you buy it standard or online. So question 1, what is the difference between the price for a standard ticket for a child, that's the 70 there, and an online ticket for a child? So 75 minus 64 is 11 kroner. Then it says, what do 2 online tickets for a child and 2 cycle tickets cost in total? Okay, so that's 2 64s, which is 128, and 2 cycle tickets, that's 2 21s, whether you buy them online or not. 21 plus 21 is 42. So 128 plus 42 is 170 kroner. Then it says, if you buy a standard ticket 3 weeks before you need to use it, you can save 20% of the price. What is the price for a standard ticket for a child that is bought 3 weeks before you need to use it? Okay, well, let's just get rid of some of the rough stuff here and think about that. So a standard ticket for a child is 75 kroner. So what you want to work out is your 75 kroner minus 20% of 75 kroner. That's one way to work it out. You could go straight to just working out 80% of 75, of course. That's another way to look at it. But I'm going to do it this way because a lot of people find this just a bit more intuitively easy to get their head round. Okay, so that's 75 minus 20% is 20 hundredths. A percentage is just a fraction out of 100. So 20% of 75 is just like, let's just tidy this up a bit. 20% of 75 is the same as 20 hundredths of 75. So 20 on the top, 100 on the bottom for 20 hundredths times 75 on the top. Okay, well, that's quite easy to do in my head because 20 times 75 I can easily do in my head. 2 times 75 is 150. 20 times 75 is going to be 1,500. So that's 1,500. And then a couple of zeros cancel on the top with the bottom to give you 75 minus 15 is 60 kroner. 60 kroner as the final answer for that one. Just try and tidy that up. Okay, on we move. A little bit behind time at the moment. I can see I'm coming up to 4 minutes and I've only done 3 questions, so I had better get a move on. It says underneath is Mikkel's list with ingredients for soup for 4 people. And it's got various ingredients. Excuse me. 10 grams of butter, 75 grams of onions, 500 grams of potatoes, 2 leeks, 3/4 of a litre of stock, and 1 deciliter of cream. Is that single cream? I can't remember. Piscafleur. Runny cream that you whip. Okay. How many grams of potatoes does Mikkel need to use for 16 people? So the recipe is for 4 people, but we're talking about 16 people. So we've got to multiply the ingredients up by 4 to get an appropriate amount for 16 people. So 500 grams of potatoes, 500 times 4 is 2,000 grams. Next question. How many people can Mikkel at the most cook soup for if he's got 2.5 deciliters of cream? Okay, well 2.5 is like 2.5. The recipe contains 1 deciliter, but he's got 2.5 deciliters. So he can cook for 2.5 times as many people. So we're looking at 4 that the standard recipe can cook for times 2.5 means he can cook for 10 people with that amount of cream, assuming he's got all the other ingredients, of course. Moving on, and what have we done? We've done about 6 questions now, and we're coming up to 6 minutes, so we're bang on time. That's good. Okay, Mikkel cycles 5 kilometers in 15 minutes. What is Mikkel's average speed in kilometers per hour? So we've got to somehow convert 5 kilometers in 15 minutes to a number of kilometers in an hour. Well, if you can do 5 kilometers... I've zoomed in there. If you can do 5 kilometers... This is going all over the place. Okay, this 5 kilometers in 15 minutes. If you multiply that up by 4... you get that he can do 20 kilometers in, I should do that in Danish, 13 minutter, 60 minutes. 60 kilometers in 20 minutes just by multiplying everything up by 4. So if he can do 20 kilometers in 60 minutes, he can do 20 kilometers in an hour. So his average speed is 20 kilometers an hour. Then it says Luna cycles an average of 18 kilometers per hour. So that means she can do 18. This keeps zooming on me. 18 kilometers in 1 hour. 1 hour is 60 minutes. So she can do 18 kilometers in 60 minutes. How long can she cycle in 40 minutes? Well, 40 minutes is 2/3 of 60 minutes, so she can do 2/3 of 18, which is 12. She can do 12 kilometers in 40 minutes. So that's 12 kilometers. 12 kilometers in 40 minutes. I mean, if you want to do this kind of a long foolproof way, then I would be setting this out as, okay, if you can do 18 kilometers in 60 minutes, then she can do 18/60ths of a kilometer in 1 minute. And if you can do 18/60ths of a kilometer in 1 minute, then she can do 18 times 40/60ths of a kilometer in 40 minutes, 40 times as much, and that works out to be 20, but it's just perhaps a little more intuitive to spot that 40 minutes is 2/3 of 60 minutes, so she can do 2/3 as much. Okay, so how far have we got with these questions? That's 1, 2, 3, 4, 5, 6, 7, 8. So we've done 8 questions, and we are up to, well, we're coming up to 9 minutes, so we're back behind time a bit. I've been waffling on. So question 9, or question 4.1. Luna and Mikkel share 0.5 litres, half a litre of soda. They get just as much each, they get the same each. How much do they each get? Okay, so they get half of 0.5, they get 0.25 of a litre each. Jasmine has bought 0.5 litres of soda, and Sophia has bought 1.25 litres of soda. So that's nicely illustrated with 2 bottles there. How much more is there in Sophia's soda than in Jasmine's soda? So it's just asking you 1.25 minus 0.5. which is 0.75 of a litre. Need to remember to do a comma for a decimal in Danish. So that was question 10. Question 11, 12, 13 and 14 are just straightforward arithmetic. So I've got a bit of a sore throat today, so you'll hear me cough a lot. Now I'll just do these written out, but I won't do much explaining because this is something you should really learn when you're younger. So the first one, 2998 plus 1999. Well, you know what? There's an easier way to do this than doing it long ways with all the carry figures. If you just think about 3000 plus 2000 is 5000, and we're just kind of 2 less than 3000 and 1 less than 2000, so it's going to be 3 less than 5000. It's going to be 4997. So I can sort of spot that in my head without having to do it the long way. Okay, 3045 minus 305. 3045 minus 305. I mean, a mistake a lot of people make is just failing to spot whether it's plus, minus, multiply or divide. But nevertheless, 0, 4, 30 minus 3 is 27, 2740, 2740, and then 12 times 250. I'm going to flip that round and do 250 times 12. So 2 times 250 is 500. And I'm going to do 1 times 250, but it's really 10 times 250, so I'll stick an extra 0 in there. And then 1 times 250 is 250. So we get 500 plus 2,500, which is 3,000. 3,000. Okay, 20,040 divided by 4. Just got to be careful to recognize that it's a division. So divided by 4, nothing, carry the 2, 5, nothing, 1 and nothing. 5010. Okay, question 15, and we're on to algebra. Okay, 5x plus 9 equals 34. I'd like to get the x bit on its own. So I'm going to take away the 9 from both sides, giving me 5x equals 25. I just want to know what x is, so I'll divide everything by 5, and I get x equals 5. Okay, just tidy up a bit there. Okay, now we've got 3x plus 4 equals 6x minus 5. Well, that's got x's on both sides. I'd like to deal with that first. So I'm going to take away 3 x's from both sides. So take away 3 x's from the left and the x's disappear. But I've got to take away 3 x's from the right. So taking away 3 x's from both sides, I get 4 equals 3x minus 5. I'd like to get the 3x bit on its own. So I'd like to get rid of the minus 5. So I will add 5 to both sides to get a 3x on its own on the right, but I need to add 5 on the left as well. So I get 9 is equal to 3x. If I divide everything by 3, I get 3 is equal to x. X equals 3 is the answer to that one. Delete that lot. Okay, next one. Oops. So I've got 6x over 4 plus 1 equals 4. I'd like to get the bit with x on its own, so I'm going to take away 1 from both sides and get 6x over 4 equals 3. I'd like to get rid of the fraction, so I'm going to multiply everything by 4. So that just leaves me with the 6x on the left, but I've got to multiply the right by 4 as well. So multiplying both sides by 4, 6x equals 12. Divide everything by 6, x equals 2. Okay, so that was question 17. And we're under 16 minutes, so we're looking good again. Write a decimal that is twice as big as 1.51. Okay, so it's just asking you 2 times 1.51 is 3.02. Write 6% as a decimal. You've got to remember that a percent is a proportion or a fraction out of 100. So 6% is 6 hundredths, which is 0.06. Write a fraction which is half as big as 3 fifths. Well, you can't write 1.5 fifths because you can't mix up fractions and decimals. So instead of halving the top, you need to double the bottom, double the amount you're dividing by, and have 3/10. Okay, question 8. Let's just see how far we are. 18, 19, 20. So this is question 21. Okay, this is just about knowing how to do calculations in the right order. So 12 plus 3 times 4 is 12 plus 12, because you've got to do the multiplication first, and that's 24. 1.2 minus 2. Well, that's going to be a negative number. What I often do in my head is to do the opposite calculation. 2 minus 1.2 in this case would be 0.8. So 1.2 minus 2 would be minus 0.8. You're just flipping the signs over. So minus 0.8 for that one. Okay, minus 2 cubed. So that's minus 2 times minus 2 times minus 2 plus 3 squared. So plus 3 times 3. You need to know that something cubed means that you're multiplying by itself 3 times. That's not the same as multiplying by 3. So we're not doing minus 2 times 3. We're doing minus 2 times minus 2 times minus 2. Minus 2 times minus 2 would make 4. Minus times minus makes plus. But multiplying that 4 by minus 2 again would make it minus again. So that would be minus 8. So that would be minus 8. Just tidy that up. Minus 8 plus, and then 3 squared is 3 times 3, which is 9. So it's minus 8 plus 9, which is 1. And then a half plus a third. Well, to do a half plus a third, you need to convert it into fractions with the same denominator. So a half is the same as 3/6. A third is the same as 2/6. I've converted it into sixths because 2 and 3 both go into 6. So 3/6 plus 2/6 makes 5/6. You just add up the tops. Okay, so that's 24, 20, 22, 23, 24. We're on question 25. And we're nearly halfway through then. Time-wise, how are we doing? Well, we're under 19 minutes, so we're well ahead of the curve at the moment. I'll take a sip of my coffee and move on. Okay, so it says the figure below shows a hexagon. Now, you might not look at that and think hexagon, but it's a side with 6 straight edges, so it is technically a hexagon. But it's also got lots of right angles in it and consists of rectangles stuck together. So it says, which expression below corresponds to the area of the hexagon for all values of a and b? So irrespective of what a and b actually are, which of these expressions gives the area of the hexagon? Well, we can break it up. So, for example, stick a line there, and you can see that this little square at the top is a times a, which is a squared. And then the length of the rectangle at the bottom is a plus b, because you've got a there and b there. So the rectangle at the bottom is a plus b, times b. So the total area is a squared for the top bit plus a plus b times b for the bottom bit. Okay, let's tidy that up. So a plus b times b, so a times b gives you ab, and b times b gives you b squared. So the total area of the whole thing can be written as a squared plus a times b plus b squared. So it's not the same as the first one. It's let's just have a look at this. See if any of these correspond to what I'm going to have to multiply all of these out, I think, to check which ones are the same. This one, a plus b squared minus a squared, so that would be a plus b times a plus b minus a squared. So that would be a times a is a squared, a times b is ab, b times a is ab, b times b is b squared, and then minus a squared on the end. The a's are going to cancel out, the a squareds are going to cancel out, so that one's not going to be the same, so it's not that one. Let's just tidy up the mess a bit. Let's have a look at this one. A plus b times b, so that's a plus b times b. A times b gives you ab, and b times b gives you b squared. It's not the same as we've got up there, so it's not that one. Running out of options now. Let's have a look at this one. This one looks promising to me. So we've got a plus b squared minus ab. A plus b squared means a plus b times a plus b, and then minus ab. So that's a times a is a squared, a times b is ab, b times a is ab, and b times b is b squared, minus the ab that was already there. Getting a bit messy, this, isn't it? So you've got an ab there and a minus ab there, which cancel each other out. So that's the same as a squared plus ab plus b squared, which is essentially what I had there. So it's going to be that one. Okay, so I'll just tidy up a bit here. Quite the mess I made there, wasn't it? There is actually, now that I think about it, a more intuitive way to think about this. Because if I just think of the whole thing as a big rectangle, and the big rectangle is a plus b along the top and a plus b down the side, so a plus b squared, so in fact a big square, and then it's had this white bit taken out of it, which is a times b, so it's a plus b squared minus ab for that reason. And if you can spot that early on, it's a little bit more intuitive than grinding through the algebra. Okay, on to question 26, I guess this is, and 27. 26 and 27. I think my my Apple Pen is running out of battery. 26 and 27. Okay, put an x in each exercise. 8 divided by 0.5. So 8 divided by 0.5. So the classic mistake would be to look at that and think it's 4, but 8 times 0.5 would be 4. 8 divided by 0.5 would be the same as 16 divided by 1, if you just double everything up. So it's 16. And then 0.6 divided by 5, 0.6 divided by 5. Well, the way I do this in my head is to double everything up and say that's the same as 1.2 divided by 10. And then divide by 10 is just easy because you move the decimal. It's 0.12. So 0.12 for that. Okay, so we're up to question 28 now. How are we doing for time? Coming up to 26 minutes, so well on schedule. I'm going to have a sip of my coffee. Okay, the sketch below shows a box with measurements. A little bit sneaky, they put the height of it in twice, so you might accidentally use the wrong information or information more than once. The volume of the box is, so the height times the base times the width, the 3 different measurements in the 3 dimensions or directions. So 4 times 3 times 3 is, what is it, 36. And then the surface area of the box. So let's just look at the front. You've got this bit here, which is, let's just, which is 12. You've got the top, which is, it's 4 by 3, so that's 12. And then you've got the side, which is 3 by 3, which is 9. So the front 3 that we can see are 12 plus 12 plus 9, which comes to 33. But then you've also got 3 at the back, so it's double that, 66. And we are on to question 30 now. I think I've deserved a sip of my coffee. Okay, how big is angle V? Well, let's try and fill in lots of gaps on this. You've got a triangle here, 54, 31. Triangle always adds up to 180. So these add up to 85. So that's got to be 95 down there to make the whole thing add up to 180. Then the V is on a straight line with the 95. Angles on a straight line always add up to 180. So that's got to be 180 minus 95, which is 85. So angle V is 85 degrees. How big is angle W? Well, let's continue to try and fill a few things in. It says the lines L and M are parallel. So there's lots of rules about parallel lines, amongst which alternate angles are equal. I don't know quite how you say that in Danish, but alternate angles are equal, which means that when you've got a Z shape like that, with 2 parallel lines forming the top and bottom of the Z, then the angles inside the Z are equal. So that 31 there, also 31 down the bottom. Then you've got the 85, the V, on a straight line with this angle in here. So that's got to be 95. Or indeed, you've got the fact that when you've got 2 crossing lines, opposite angles are equal. So it's 95 because it's got a 95 opposite it. And then, in fact, I didn't really need to think about any of that because I've just spotted that there's a 54 there. And the 54 forms a Z shape with 2 parallel lines, with the 54 at the top and the W at the bottom. So it's 54 because it's an alternate angle with the 54 at the top. So Z shape with two parallel lines, angles are the same at the top and the bottom. Okay, so that's question up to question 32 now, I think. And we are on just under 31 minutes. A sip of coffee. Okay, it says the line S, or the line S and the line T are drawn below in a coordinate system. The line S cuts the y-axis at what point? So that point there we're talking about. I'm just having a little bit of trouble with my pen here. Why doesn't that want to play? There we go. So that point there, 0, 5. 0, 5. And then it says the lines S and T intersect each other at what point? So scare is intersect. So if you can imagine the line S and the line T going back a bit, where will they meet? Okay, well you can see that line S is going 2 across for every 1 up. So by the time it goes 2 down there, it will have gone 4 back there before it meets the line T. So it will be at the point -4, 3 back there. You can work that out with algebra and equations of the lines, but on these questions, on this type of exam, you can typically just sort of extend the diagram a little bit and figure it out from there. It's not a very elegant approach, but there it is. Okay, and I think we're on to question 34 now. And just coming up to 33 minutes. Okay, so the sketch shows 2 similar quadrilaterals, AEFG, that's the little one, and ABCD, that's the big one. So they're similar, which means they've got the same angles, they're the same basic shape, they're just in different proportions. It says that the length relationship, the ratio between AEFG, that's the little one, and ABCD, that's the big one, is 1 to 3. So that means all of the lengths in the big one are 3 times the lengths in the little one. So where you've got a 4 there, that's going to be 3 times as much, 12 in the big one. Where you've got an 18 there, that's going to be 1/3 as much, 6 in the little one. So it says the length of side AB is what? So AB from A to B, well, I've already answered that, that's 12. The length of side EF, so that's from E to F, well, I've already answered that, it's 6. And the area of quadrilateral ABCD is how many times as big as the area of AEFG? Well, you might make the mistake of thinking that it's 3 times as big because the lengths are 3 times as much. But when you calculate an area, it's in 2 dimensions. So it's 3 times as big lengthwise, but it's also 3 times as big height-wise. It's 3 times as big in 2 dimensions. So it's actually 3 times 3, 9 times as big. And you can sort of see that from the fact that if you draw on it, you can fit 9 of the little ones into the big one. Bearing in mind that these things are never drawn to scale. You can see it says skizze here, sketch. if this was an English exam, it would have the disclaimer along the lines of diagrams are not drawn to scale. So they always make the diagrams in exams a little bit wonky so that you don't get the answer just from measuring them. Okay, so we're up to question 37, I think. I'm going to have a sip of my coffee and give my voice a much needed break. Excuse my coughing. And some water, I think. So we are up to, not yet up to 36 minutes. I'm trying to go a minute a question, so that should take 50 minutes. So that should give me 10 spare minutes at the end. Okay, right. So write or rewrite 0.73 kilograms in grams. That's 730. There's 1,000 grams in a kilogram. 2,150 millimeters in meter. So again, that concerns 1,000. Anything with milli or kilo tends to be about to do with 1,000. So that's going to be 2.15. Yeah, a meter is bigger than a millimeter, so there's fewer of them. 1.25 litres in deciliters. Anything with deci is 10. There's 10 deciliters in a litre. A deciliter is smaller than a litre, so you expect there to be more of them. So it's multiplied by 10 rather than divide by 10. 12.5 deciliters. And then 2.5 meters cubed in a litre. Now, this kind of relates to what I said in the previous question about length and area and volume. So a meter cubed is a meter by a meter by a meter. If you put that in centimeters, that's 100 centimeters times 100 centimeters times 100 centimeters. 100 times 100 times 100 makes a million. So 1 meter cubed equals 1 million centimeters cubed. Now, by definition, 1 litre, perhaps I should write that in Danish, litre with ER, equals 1,000 centimeters cubed. So that's information you ought to know. So in other words, if 1 litre is 1,000 centimeters cubed and 1 meter cubed is 1,000,000 centimeters cubed, then 1 meter cubed is 1,000 litres. This is going all over the place. 1 meter cubed is 1,000 litres. We're talking about 2.5 meters cubed. So that's 2,500 litres. 2.5 times 1,000, in other words. Okay, so that was questions 38, 39, 40. So we're into the home stretch here with the last 10 questions. Question 41. Well, I'm just going to have a sip of my drink again. Try and preserve my voice. Just coming up to 39 minutes. Okay, so it's a prism. So it says below is a sketch of a prism. So a prism is anything that's got kind of the same shape on one end and at the front and at the back and all the way throughout. So it's got a constant cross section. If you cut it anywhere along the middle and take a slice out, it'll still be the same shape. Very badly drawn, a little bit difficult with the old Apple pen. And the volume of a prism is just the end area multiplied by the length that end area extends throughout. So if we can work out the area of the trapezium at the end, and multiply it by 8, that will be the volume of the whole thing. So it says here in Danish, below is a sketch of a prism with a grundflade, an end area, a basic end area that has the form of a trapezium. The trapezium is green on the drawing. In the yellow box is the formula for the area of a trapezium. Oh, that's helpful. So A is the area of the trapezium, H is the height of the trapezium, which we haven't been told. And A and B are the parallel sides of the trapezium. Okay, but we have been told in very small letters underneath that you could easily miss. The area of the trapezium is 8. Okay, so the area is half times the height times A plus B. We're told that the area is 8. So area is a half times the height times, and then A plus B is the 3 and the 5. Excuse me. 3 plus 5. Okay, so 8 equals a half times the height times 3 plus 5 is 8. A half times 8 is 4, so 8 equals 4 times the height. And divide everything by 4, the height is 2. So the height of the trapezium is 2. And then it says you've got to work out the volume of the prism. Well, it's quite helpful that they've told you already that the end area is 8. So without having to do that calculation, they've told you everything you need to know for the second bit of the question without needing to get the first bit of the question right. So it's just the end area of 8 times the length that it extends throughout, which is 8. 64. Prism volume is always end area times length. Okay, so where are we up to in questions? 38, 39, 40, 41, 42. We're up to 43. And we're coming up to 43 minutes. I'm going to preserve my voice and have another drink. Okay, which triangle is leaciate? So you've got to know what that word means. That's, in English, equilateral. All equal sides and angles, and that's clearly B, because it's got 3 60-degree angles crossing B. Statistics and probability. The table shows how many pupils have 0, 1, 2, 3 or 4 TV screens where they live. So there's 3 people with no TV. Most people, 12 people, have 1 TV. 8 people have 2 TVs. 2 people have 3 TVs, and 1 person has 4 TVs. Which diagram suits the table best? Okay, let's have a look at this. So you've got increasing number of people having different TVs and 4%. That makes no sense at all. So not that one. You've got 3 other diagrams that appear to go up and down correctly, but the question is the scaling here. So let's try and do some calculations. Let's see how many people there are in this. So 3 plus 12 is 15, 25, 26. Okay. So the number of people with 1 TV is 12 out of 26. times 100 to make that a percentage. I mean, it's in the order. Without doing much calculation, I can see that it's in the order of something just under a half. So 12 out of 26 is just under a half. So that's going to be something like 40-something% without doing a lot of calculation. So, you know, I can see that that one's right, because this one has more than a half of the people having just one TV, 60%, and we know it's less than half. And the others are just kind of ridiculous. Or another thing you can do is just add up these percentages. So you've got 3% there, 12% there, 8% there, 2% there, 1% there. That should add up to 100, but clearly doesn't. Whereas these, that looks like 12%, maybe 46%, maybe that's 31%, give or take a bit of rounding. That looks like 8%. That looks like 4%. So 12, 58, 88, 89 plus 13 adds up to 102. So give or take a bit of rounding. It is clearly that one there. Okay, box plot. Question 19. It says the box plot shows the distribution of 200 pupils' heights in centimeters. So you need to know what a box plot does. A box plot shows you the lowest and highest value in a group of data. So the shortest person was 156 centimeters. The tallest person was 195. And then it shows you the median and the quartiles. So what does that mean? Well, if you stand the 200 people in a long line in height order, with the smallest at one end, 156, and the tallest at the other end, 195, then the person who's standing exactly in the middle is 174. So if you like, that's the 50% person, the person who's 50% from one end and 50% from the other end. So that's the median, in other words. But then you've got the quartiles. So the person who's standing 25% from the bottom end, so he's a quarter of the way up the data, he or she, that person is 169 centimeters tall. Then you've got the upper quartile, which is the person who's 75% of the way along the line. So it's the person who's at the top quarter of the data, and that person's 180 centimeters. So with all that discussed, let's just clear some of this mess and talk about this. So it says the pupils' heights vary from 156 to how many centimeters? 195, lowest to the highest. What percentage of the pupils are between 169 and 180 centimeters tall? So that's the box in the middle. So as discussed, the box and whisker plot shows kind of the bottom end of the data, the top end of the data. So all 100% of pupils are 195 centimeters or below. It shows you where the middle of the data is. So the middle point is 174. So somebody who's 174 centimeters is halfway from the top to the bottom. They're in the middle. They've got 50% of the people above them and 50% below them. And then it shows you where the top and bottom 25% are. So the person who's just at the bottom 25% is 169 centimeters. The person who's at the top 25% is 180 centimeters. And then everybody in between is in the middle 50%. So 50% of pupils are between 169 and 180 centimeters, because those are the upper and lower quartiles. Okay, and then finally, 75% of pupils are at least how many centimeters tall? Okay, well, you've got to be a little bit careful here, because it's at least. So what it's saying is, where is the top 75% of the pupils? So although the 169 is for the bottom 25%, that 169 marker cuts off the bottom 25% and the top 75%. 169 people has 25% of the people below it and 75% of the people above it. So 75% of the pupils are at least 169 centimeters tall. So 169 centimeters or taller. So you've got to be a bit careful there, discerning between the top 75% and the bottom 75%, and then not getting that the wrong way around. Okay, probability, and we're nearly at the end now. Last 3 questions. How are we doing for time? 51.5 minutes, so I've gone a little bit further waffling on than I wanted to. Another drink of water. So we've got about 8 minutes for the last 3 questions. Okay, so Mikkel has 2 special dice. On the blue die, he can throw 10, 10, 20, 20, 30 or 30. Okay, so it's got 10, 10, 20, 20, 30, 30. So it's not going 10, 20, 30, 40, 50, 60. And on the red one, the numbers say 1, 1, 2, 2, 3, 3. So there's no 4, 5 or 6. Mikkel throws the 2 dice. The chance of the red die showing a 2 is... Okay, well, there's 2 2s out of 6 things it can land on. So it's 2/6, which is the same as a third. Mikkel wants to find the sum of the numbers on the 2 dice. What is the chance of the sum being 33? Well, what you could do here, and this is going to be a little bit time consuming, but it's a good way to approach it, is to make a table of the possible outcomes. So on the blue one, you can have 10, 10, 20, 20, 30 or 30. On the red, you can have 1, 2, 3, 4, 5 or 6. So you could do a table of all the possible totals: 11, 11, 21, 21, 31. I'm going to quickly whiz through this. 31, 12, 12, 22, 22, 32, 32, 13, 13, 23, 23, 33, 33, 14. I've just made a stupid mistake, haven't I? Because it doesn't go 1, 2, 3, 4, 5, 6. It goes 1, 2, 3 again. So let's delete that. Boom. Okay, so we're going 1, 2, 3. So that's 11, 11, 21, 21, 31, 31. In fact, that's just the same as the ones we calculated before, isn't it? So I'll just quickly sneaky copy those and paste. There we are. Okay, so the chance of the sum being 33. So that can happen with a 30 and a 3, and there's 4 ways that you can get the 30 with the 3 out of the 36 ways it could end up. So it's 4 out of 36, which is the same as a ninth. And then the chance of the sum being greater than 20. Well, again, we can just look at our table of all the possibilities. So ways we get greater than 20, all of those, 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 all of those. I mean, it's essentially if the blue die lands on anything other than 10, isn't it? So there are, let's just count these up, 24 ways out of 36 that you can get a sum greater than 20, which is the same as 2/3. So 2/3. Okay, so we're done with that. That's taken us 56 minutes, so just a tiny bit of time to spare. But I did a lot of explaining along the way.